Unit 12 is Kinetics and Thermodynamics. Kinetics, you have the collision theory. It's the order for a reaction to happen. In order for the reaction to happen, reactants have to collide with each other. They have to collide with enough energy. That amount of energy we actually call the activation energy. And they have to collide at the right spot. So they have to hit each other just at the right orientation to cause the reaction to occur. Reaction rate is the change in concentration per time. So you have bonds broken versus bonds formed. You have to first break the bonds of the reactants and then put them back together as products. So rate influencing factors, because the more collisions you have, the faster the reaction goes. So if you crush up the reactants or increase the surface areas of the reactants, there's going to be more collisions, so the reaction occurs faster. If you increase the temperature, you're increasing the kinetic energy, so you'll have more collisions, and so the faster the reaction. If you increase the concentration, you have more things, there's going to be more collisions, so the faster the reaction. If you add a catalyst, what you're doing is you're increasing the rate without being consumed by lowering the activation energy. So it requires less energy to actually occur, so you're going to have more collisions at that lower energy, so the faster the reaction happens. So hopefully you realize by now you have to have reactants first. They collide with enough energy, hitting each other at the right spots, and they produce products. The activation energy is the energy required to transform the reactants into the products. That would be the activation energy for the forward reaction. You could also have activation energy for the reverse reactions, where our products are colliding with enough energy and hitting each other at the right spots to reform our reactants. So we actually have a graph, the potential energy diagram. How much energy do we need for this reaction to take place? So on the y-axis you have potential energy, and then you have time or rate as the x-axis. So these are some things that you need to be able to identify. You always start a reaction as a reactant, and you always end a reaction as a product. So the potential energy of the products would be the arrow that goes from the the x-axis to the spot where our products are found. Potential energy of the reactants would be from the x-axis to the reactants. Now, in between a reactant and a product, you could have an intermediate. So this is a compound that is not a reactant nor a product. It just happens in between. So the potential energy of the intermediates would be the arrow going from the x-axis to the intermediates. Now there's another word for intermediate, and that is activated complex. So the amount of energy we need to go from a reactant to the product is our activation energy of the forward. So that's how much energy I need to go from being a reactant to going to the intermediates, or the top of my hill. So the activation energy of the reverse would be how much energy my products need to go back over the hill. And again, intermediate is the same thing as an activated complex. Our products are what we always end with. Our reactants are always what we start with. The difference between my bonds broken in my reactants and the bonds formed of my product is called the heat of reaction. How much heat actually changed. And that is symbolized by delta H. So if I start with more reactant, if I have need more energy as a product, then it's an endothermic reaction. So this graph is an example of an endothermic reaction. My reactants have less energy than my products. An exothermic reaction, my reactants would have more energy than my products. And then we could give some values using the numbers off the side. So the potential energy of my reactants would be 30 joules. Joules is a unit for energy. The potential energy of the products would be 40 joules. Heat of reaction then, I would say 30 minus 40 or 40 minus 30, 10 joules. The potential energy of the intermediates would be 60 joules. So to go from reactants to intermediate, 60 minus 30, my activation energy would be 30 joules. For the reverse, I'm starting at 40. So 60 minus 40, the activation energy for the reverse would be 20 joules.